ang bagong project. Oh. Ano na naman yan? Ah? Oh, ito. Ito ay tinatawag na dimmer switch using transistor, potentiometer, at meron ding resistor and LED as an output. Ay, ano naman ang gawa niyan? Ah? Aba, dimmer switch. Ididim niya yung LED. Lalagyan natin ng supply para makita natin kung paano gumana. Supply natin 5 volts. Oh, ginawa kong power supply. Ano yan? Adjustable. Okay? O yan. O. Subukan natin. Diba? Nadidim niya yung LED habang iniikot mo yung potentiometer. On, off, on, This is now the circuit diagram of our project. We're using one transistor 2N2222A NPN type BJT, and to the collector we're using white LED as an output. That is the one that is turning on and off and with current limiting resistor in order not to burn this LED, to burn out this LED. As you can see here, the base of the transistor is connected to the pin 1 of the potentiometer, and we are using a 5 volt supply. For the potentiometer, we have this 50K. If this is the potentiometer, we have 3 legs of the potentiometer, 1, 2, 3. The middle is the wiper. That is the one that is rotating, or when you turning it, it rotates to the right, the wiper. So when you rotate it from left to right, as if the equivalent of that to our circuit diagram is, it will move upward. Okay? When you rotate it clockwise, it will move upward. So, but the initial state of the circuit, it is pointing to the pin 1. The wiper is pointing to pin 1. And it is grounded. So, the base of the transistor is grounded. What happened to the circuit if the base is grounded? The current flows into the potentiometer with 50K resistance, which flows directly to the ground, and the base is grounded. So the base of the transistor, base to emitter, voltage at the base to emitter is equal to 0 volts. So there's no voltage across voltage to emitter of the transistor, which is 0 volts, making this transistor to turn off. So there's no light into the LED because the transistor is off, grounded. When you move the wiper or rotating the wiper or turning this wiper to the right, as if in the circuit, the wiper 2, that is the wiper, is moving upward. That is the equivalent for rotating moving this wiper to the right clockwise. When you move the wiper to the right, when it moves upward, there is now a current between the ground. What is now the configuration of the biasing or the biasing of the transistor? It is now a voltage divider biasing type of configuration for this transistor. 2 voltage dividing a voltage between the base to emitter and then the 5 volts from the 5 volts and then base to the emitter. We need at least 0.7 volts to turn this transistor on. When the wiper moves upward, it receives a small voltage will develop across base and then the emitter because of the resistance. So the LED is turning on, or slowly turning on. When we move the wiper, at least I think 9 o'clock. When you say 9 o'clock, you move the wiper to this position, or this the knob moves in a 9 o'clock position. 9 o'clock. This is a 9 o'clock. As if in the circuit diagram, the wiper moves to the middle of the resistor. It will now turning this transistor on because it receives 0.7 volts. That's why this LED is slowly turning on and is slowly turning off. Once it receives a voltage of 0.7, it will fully turning on this transistor. The voltage developed. Is there any current that flows into the base? There's no current. It's just a leakage current. We are talking about the voltage divider biasing. It is the voltage developed across base to emitter. That is the one responsible for turning this transistor on. If this transistor receives 0.7 volts, it is not a current. Current is a leakage current, only flows into the base. Even though this transistor is a current driven device, it is because of the biasing of the transistor now is more important. That's why when the transistor receives 0.7 volts across the base to emitter, upon turning this potentiometer or moving this wiper upward, it will fully turning on this transistor. So the LED now receives current. The current flows from 5 volt supply to the resistor LED and saturating this output side of the transistor, or act as a closed switch, and the current flows to the collector, to emitter, and then to the ground, turning this transistor on. So when voltage developed across base to emitter is 0.7 volts, it will turn on the LED and this transistor because of the resistance. The current flows, the resistance and the voltage developed across the base to emitter with the help of this resistor. So you can but if you fully if you move the wiper or the knob of the potentiometer, it will short the transistor because the current flows into the into the BCC and then directly to the base of the transistor. What happened to the transistor? It will damage or destroy or will not operate this transistor. It will burn this transistor because of too much current that flows from BCC to the base. If you pulley moving this or turning this the knob to the right or moving it upward, there is no resistance now for the transistor. It will burn out this transistor. So it is better to move it just into the middle of the potentiometer. We just make it a 9 o'clock or at least 10 o'clock to the knob of the potentiometer.